All right, hello everyone. Today we're diving deep into the constellation Dorado. Now, you might not know it for its bright stars, it doesn't really have any spectacular ones, but what it lacks in visual glamour, it more than makes up for with its incredible scientific importance. I mean, this patch of sky holds the southern ecliptic pole and our closest major galactic neighbor, making it absolutely central to modern astrophysics. So, let's get into it.
And right away, we run into the central paradox of Dorado. On the one hand, it's tiny. I mean, look at it. It ranks 72nd out of 88 constellations in terms of sheer area. It's pretty unassuming. But on the other hand, it's home to this, the Large Magellanic Cloud, which is the reason for its absolutely colossal scientific status. And it's this very contrast, this tension between its small size and its immense importance, that's really at the heart of what we're going to explore today.
Okay, so here's our game plan. We'll start with the basics, where you can actually see Dorado from here on Earth. Then we'll journey into the heart of its wonders, the Magellanic Cloud. From there, we'll zero in on some truly unique prototype stars, circle back to look at its human history, and finally, we'll put it all together to understand why we call it a cosmic laboratory. All right, first up, celestial geography. Before we can really dig into what's in Dorado, we first have to figure out where it is, and more importantly, who on Earth can actually see it. Because, as you'll see, its fan club has some pretty strict geographical limits.
So Dorado is a deep southern constellation, which means your latitude on Earth is everything. If you're south of 20 degrees north latitude, you're in luck. You get the full show. Between 20 and 40 degrees north, well, you might just catch a glimpse of it skimming the horizon. But for anyone north of that, sorry, it's permanently hidden from your view. And on the flip side, if you go way down south below 20 degrees south latitude, Dorado becomes circumpolar. It just circles the pole, never setting at all. Okay, now that we know where to find it, let's get to the main event, the crown jewel of Dorado, the Large Magellanic Cloud, or the LMC. This satellite galaxy is, and I don't say this lightly, an absolutely unparalleled laboratory. It gives us a chance to study processes that happen in other galaxies, but right on our cosmic doorstep. And just to give you a sense of what doorstep means in cosmic terms, we're talking about 163,000 light years away. So let's be perfectly clear. This isn't some star cluster inside our own Milky Way. This is a completely separate galaxy. But it's also incredibly close in galactic terms. And that proximity is the key. It lets us study it with a level of detail that's just impossible for galaxies millions of light years away. Now, deep inside the LMC, there's a place called the Tarantula Nebula. And forget any idea of a calm, serene cloud. This thing is a beast. It's a hyperactive stellar nursery, a furious cauldron of ionized gas stretching nearly 1,000 light years across. It's churning out thousands upon thousands of new suns. In fact, it's the most powerful, most violent star-forming region in our entire local group of galaxies. Nothing else even comes close. To really wrap your head around how incredibly bright this thing is, try this little thought experiment. Imagine we could just pick up the Tarantula Nebula and move it to where our own familiar Orion Nebula is. If we did that, it would completely dominate our view. It would stretch across half the sky. It would be so bright it would actually cast shadows at night, and you'd easily be able to see it during the day. Just try to picture that, an absolutely mind-blowing spectacle. And the LMC is just packed with these kinds of astrophysical extremes. Right in the heart of the Tarantula Nebula, you've got R136A1, a star so ridiculously massive, over 200 times the mass of our sun, that it honestly pushes the limits of our theories on how stars can even form. Then there's N44, this giant superbubble of gas, 250 light years across, carved out by the ferocious winds of young hot stars. And you've even got LMC X1, a powerful X-ray source that was one of the very first black hole candidates ever identified. And then there's Supernova 1987A. This is stellar evolution playing out right before our eyes. Back on February 23rd, 1987, a blue supergiant star in the LMC just blew up. It was the closest supernova seen in centuries, and it was bright enough to see with the naked eye. What we see today is incredible. It's not just a fading cloud, it's this beautiful glowing ring. What you're actually seeing is the supernova's shockwave slamming into a ring of gas that the star itself ejected before it died. It's a cosmic scale collision, and we have a front row seat. All right, let's move on. Beyond the spectacular LMC, Dorado also contains individual stars that are famous in their own right.
In fact, some are so unique, so special, that they've become the actual prototypes for entire classes of stars. They literally define the categories we use to classify them across the universe. We're talking about three main examples here. First, you have S Doradus. It's the original luminous blue variable, or LBV. These are massive, incredibly unstable hypergiants that are constantly on the brink of tearing themselves apart. Then there's Gamma Doradus, the prototype for stars that pulsate with complex waves rippling across their surfaces. And finally, AB Doradus, which is the textbook example of a young, super-fast spinning star with an extremely powerful magnetic field. And if you want to talk about extreme physics, just look at this star, VFTS 102. It's spinning at over 500 kilometers per second. That is so incredibly fast that the centrifugal force at its equator is barely held in check by its own gravity. The star is literally a hair's breadth away from flinging itself apart. It's a perfect example of the kind of insane dynamics we find in Dorado. Okay, let's pull back from deep space for a bit and look at the human story behind this constellation. We're going to dive into how it was first mapped, the arguments it sparked among astronomers, and its very unique mythology, one that doesn't come from the ancient Greeks or Romans, but from the Age of Sail. So its history on our maps is actually a little messy. It was first charted around 1598 by Petrus Plancius, based on observations from Dutch sailors. But then, in 1627, the great Johannes Kepler suggested a different name for it, Xiphias. This kicked off centuries of confusion in star atlases. It wasn't until 1922 that the International Astronomical Union finally stepped in and made Dorado the official name, settling the debate once and for all.
And the whole source of this mix-up basically comes down to two different fish. See, Plancius's name, Dorado, refers to the dolphin fish, or mahi-mahi, a tropical fish known for its golden shimmer. Kepler's name, Xiphias, is Greek for swordfish. So what happened for hundreds of years was that you'd see star charts labeled Dorado, but the illustration would be a picture of a swordfish, a classic case of cosmic mistaken identity. Since it doesn't have any ancient Greek or Roman myths, Dorado got what you could call a mythology of the Age of Sail. Sailors in the southern oceans would constantly see dolphin fish, the Dorado, chasing after flying fish. It was a daily drama for them. So they just projected that same story onto the night sky. And that's why, up there in the heavens, the constellation Dorado is forever chasing its neighbor, Volans, the flying fish.
And that brings us to our conclusion. Let's tie all of this together and really hammer home our main point, that this small, unassuming constellation is actually one of the most critical cosmic laboratories we have for understanding the universe.
So, when you boil it all down, Dorado's importance really rests on four main pillars. 1, it contains the south ecliptic pole, a critical reference point for celestial mechanics. 2, it hosts the large Magellanic Cloud, our absolute best place to study another galaxy up close. 3, it's home to those stellar prototypes that are literally the benchmarks we use to classify stars. And 4, it gave us Supernova 1987A, our most detailed look ever at the death of a massive star. It's an incredible resume for such a small constellation. So we'll end with a question looking to the future. When you consider the sheer density of unique objects and cosmic laboratories packed into this one little patch of sky, you just have to wonder, what else is waiting for us in there? What other fundamental laws of the universe will be revealed by studying this modest constellation? The exploration of Dorado is really just beginning.